Okay, welcome back to another engineering economics video. We are in the middle of chapter 6, looking at annual equivalent analysis. We've looked at annual equivalent worth, and now we're looking at annual equivalent cost. So we want to look at an example. This is example 6.2 from the textbook, where we are analyzing annual equivalent cost, or the cost of ownership. Or this is also called the capital recovery cost. So what we have here are two automobiles, a BMW M3 and a Hyundai Accent. We're just going to look at the BMW for now. And we want to know how much it costs per year to own this vehicle, what its annual ownership cost is. And we are going to assume that we have an interest rate of 6% compounded annually. And in addition to that, we have not just a static value of our vehicle. The longer we own the car and the more we drive it, the less its value is. After 2 years, the vehicle is only worth 70% of what it originally is. And after 3 years, it's only worth 60% of its original worth. And after 4 years, it's 51% and then 43%. And then at the end of 5 years, we are going to sell the vehicle. And so we want to know, over those 5 years, how much did it cost us to own that vehicle? So this is how we're going to do that. This is how we're going to calculate capital recovery cost of an investment. So I've already set up a spreadsheet. I've sort of set up a template here that shows us the number of years, the value that the vehicle or equipment is going to maintain in terms of percentage, and then what its value is in terms of dollars. So initially, at the end of year 0, or at the beginning of this 5 years of ownership, the vehicle is worth 100% of its $58,400 dollar suggested retail price. Now, we're not given in the original problem statement, we're not given a percentage for what it's worth after 1 year. So we'll just leave that row blank, or we could just delete that row and jump right into year 2. At the end of year 2, it's going to be worth 70% of that original value. So I'll use Excel to calculate that for me. So I'll write a formula that is equal to 70% times the 58,400. Except I want to be able to copy this down, and these percentages are percentages of the original value. They're not percentages of the previous year's value. So I need to adjust this formula. This cell reference to cell C2, I need it to stay in row 2. So I'll put a $sign, $2. And that way, when I copy these values down, I'm finding 43% of the original price, or 51% of the original price. So this tells me what it originally cost and what it was worth at the end of year 2, 3, 4, and 5. And at the end of year 5, we're going to sell the vehicle, and we're going to assume that we sell it for what it is worth. So the initial cost of our vehicle is this, $58,400. The salvage value is the $25,112. That's what we're going to sell it for in the end. The interest rate we're given in the problem statement is 6%. Now, in order to determine the annual cost of ownership, first we need to find out what the net cost of the vehicle or equipment was. So that's going to be equal to the initial amount minus what we sell it for. So that's the first piece of information we need. Yes, we bought it for $58,400, but at the end of 5 years, we're able to sell it for $25,112. So really, it only cost us $33,288. Now we would like to take this total amount and spread it out over 5 years. But again, because interest rates are involved, we cannot just take this value and divide it by 5. We need to take this value and calculate its annual equivalence using a payment function. So this is equal to the payment function with inputs of 6% for our rate. The number of periods is 5. And we want to put in this value, this net value that it cost us to own the vehicle as our present value. We're going to take that and we're going to spread it out over 5 years. Except I'll make that negative so that the equivalence comes out positive. So just based on taking our net cost and using the payment function to spread it out over 5 years, we get $7,902.45. That's the annual cost of owning this BMW, except to calculate what the textbook calls a capital recovery cost, we also need to include an opportunity cost. And what that opportunity cost is that for every year that we own this car, every year that we own it and we don't sell it, we are potentially losing interest. We are losing the opportunity to earn $25,112. We could, instead of owning this BMW, we could sell it. Now, in each of these given years, that value is changing, but worst case scenario, in our last year, this is our lowest value, worst case scenario, at any point in time that we owned this vehicle, we could have sold it for $25,112. And we could have taken that money and we could have invested it. So we could have earned 6% of the salvage value in any given year. But we didn't. Instead of selling the car and investing the money, we kept the car. So that's a cost. That is a cost to us. And that is equal to, it's just a simple interest calculation of taking our interest rate multiplied by the salvage value. So what we are saying here is that the total capital recovery cost of owning this vehicle on an annual basis is equal to its net value spread out over 5 years using a payment function, plus the opportunity cost that we deferred, that we did not take advantage of by virtue of the fact that we own the vehicle instead of selling it and investing that money. So the total cost of ownership, or also known as capital recovery cost, on an annual basis for this vehicle over 5 years is $9,409.17. So this type of capital recovery calculation is something that we're going to do several times throughout the semester. And in years past, I've always referred to or reminded students, remember that example problem we did with the BMW, where we had to, find its annual equivalence and then add the salvage interest to get that capital recovery cost. That I know that has come up several times in years past. So this is kind of an important example problem that we'll refer back to later on in the semester. So I think I'm going to stop here. I'm going to try keeping these videos maybe a little bit shorter. That might make them a little bit more user-friendly. And we'll look at one more example problem in the next video. So see you then.